Good morning and good greetings. I'm glad I'm finally here to speak with people who are so involved in ferrocement. Probably you will help this become a better project if it ever happens, because you know more than I would about ferrocement. I approached a problem that I saw. I traveled to Thailand a few times, and the Philippines and Mexico, and I had worked on a ferrocement sailboat, and in the Virgin Islands I saw a hurricane destroy property and buildings, and I knew that water was 800 times as dense as air. So I asked the fellow who I worked on the boat with, why don't we turn your boat inside out? And it'll be very strong, and houses won't blow away. Anyway, I started studying the Virgin Island building code, and one thing that seemed important was the water collection. In the building code, every square foot of roof area has to be able to collect and store 10 gallons of water. And you have to have a cistern. Anyhow, ferrocement lent itself to the solutions of the cistern and the strength of the building, and I started studying it more. And Dr. Lilia Austriaca and I started to communicate, because she was the president or the secretary of the Ferrocement Society, and I wrote a paper about this design that's right there. And it was accepted pretty well. And as, of course, they always said, oh, you never built one, and there were no calculations. So I did. I went down to Mexico and I built one with a lot of help from various people, like Professor Hernandez at the university in Mexico, and Professor Tony Nauman. He gave me a lot of advice, not about the armature, about the cement work. And I have a background in construction for 50 years, so I was very familiar with development of shapes. And I noticed, as I wrote here, imagine a line, a form, or a utilitarian purpose, and ferrocement will follow and create it materially with an aesthetic three-dimensional strength and durability. So I said, aha, this is a very good thing, because you can almost do what you want. Then I discovered you had to have it pass codes, building codes. And I was familiar with that because that's what I did in New York. I worked on renovations and conforming old buildings to the current code. I actually used ferrocement, not knowing I was using ferrocement. I was fireproofing the walls. You needed 1 hour code fireproofing. So the exterior buildings were stuccoed basically on wire, and I realized what it was. So anyway, I'll try to be quicker. We should go to the next one. And I had read about, I went to the World Housing Technology Center in Izmir, Turkey, because I was studying housing. I was about 40 years old, and I was very into it. And I noticed there was no Volkswagen of houses, I'll call it, a people's house. I went to the UN's meetings and different meetings, and the big deal then was styrofoam with some kind of polyester or polymar on it or something. This illustration was done by Haejung Park, who's a very wonderful illustrator, and so are there many others. So here's a building I started to build in Mexico, as I had mentioned a minute ago. And turns out that it worked. In other words, my plans, which I had never built yet, I went down to Mexico with templates. And as you've seen other people here, they lay it out on the ground and all that. I did that. But I knew the connections would work, because I have a background in sheet metal layout, so ductwork. I'm a journeyman in Local 28 in New York City, and we did a lot of large squared around buildings, squared around ducts. And one building that I designed came off of that knowledge, the layout. So, and a lot of work that I hear from, a lot of the presentations that I hear is very little to do with the shape of the building. It's either the obvious flat, like all buildings, or not all buildings. I mean, I just saw a beautiful brick wall over there. It was amazing, actually. It looks like it should be near ships. It's like a ship. Anyway, the radial line development that I learned in the trade of sheet metal lent itself to ferrocement. And I was very familiar with reinforced concrete and armatures. And I decided for anything to be in a code, it has to have insulation. The simple things, insulation. And I noticed of the ferrocement buildings that existed at the time that I was studying, there was no insulation. I was in a few that Professor Hernandez had built in Mexico, beautiful buildings, and they had major trouble with air conditioning and like a little rainstorm inside the building because it was so hot outside, and inside they're trying to air condition it. So it didn't work. So I decided I'm conforming a building to code when I designed this. And it did, by the way, become a building that's conformed to code. Somehow, oh, there it is. Here we go. Okay. I must say, I haven't seen this presentation since I made it a month and a half ago, maybe. Okay, this is interesting. As I developed more and more, I noticed that a lot of the aspects of the intact structures building system can retrofit existing block buildings. See, I'm looking at this small. You see it nice and big, right? Okay. So the same roof system that's on the building that I built in Mexico can be placed on top of a block building that lost its corrugated roof, say. In fact, there was a man that made a presentation yesterday from Pakistan on a Zoom, and he was using ferrocement to strengthen the building, but he was talking about the corrugated roof. And I was saying, well, as you see on the top of this, right there, up here, you could easily see this. And I wanted to do it in Mexico, but I never got back. I had some health conditions occurred, and COVID and things. And it didn't happen. But I was starting, that's my shadow, taking a picture of it. And this is an illustration of what a retrofitted block building that was half happening with no roof. You could easily put a ferrocement system on top of it with these components, and it would also strengthen the walls by the legs coming down. And it would have a gutter system that then gave that building a water collection system. Okay, next slide. I'm boring everybody, perhaps. Okay, then my mind kept working, and I had visited various places like the Philippines and Thailand, like I mentioned. And yeah, I went to slums and what they call, what do they call it when they move people? I forget what they call it. Anyway, and the people weren't happy. They moved them too far away. And the porches on the buildings that they made for them, there was enough cement to build 5 ferrocement houses. There was like cement. And no water collection, like a hose spigot outside. It was pretty nuts to see, and they spent a lot of money. So I was introduced to slums with people complaining that they were relocated. They wanted to stay where the slum was because that's where they came from or lived originally, and because of either a highway or urban development had made them move. Say their grandfather lived in that area and they had a village, but now they all had to get pushed into a little place, and they were probably given faulty building material to build the slums or something. Anyway, it was a problem. So I, as you see in this illustration, I created something I call the oasis, which would be a solution to a slum. And I believe this presentation is in the conference's book.
Yes.
So you please read it if you would like it. And this building system is 4 components, which you see sometimes. You see them here. There must be a slide with, there may not be a slide that hold on. I'm looking for the table, the fabrication table. Okay. It's in the book, I would think. This isn't the book, this is the presentation. There's more in the book. So anyway, it adapts to self-sustaining construction that people can learn vocations and that will carry them through to the next stage of their life. They not only learn about ferrocement construction, they'll learn about, say if they built the oasis, they'll learn about food propagation, a fish farm perhaps, which I saw in the Philippines. There was a lot of people trying to have fish farms with barrels. Yeah. You walked along the street, there's barrels of fish. They could have just had a ferrocement pool and would have many fish. And they probably could run it better. Here we go. Now, I was asked in Thailand by a Dr. Ekasit Limsuwan, a very good friend of mine and a very smart guy who liked intact structures. He said, could you possibly make an Asian design at a ferrocement? And often I've been asked, can I have a different roof? Because supposedly this kind of roof is not. I must say, they didn't like the style of a Volkswagen, and it became the most popular car in the world. But even though it was the Beetle. So I think this system could be the Volkswagen of houses. Being that it'll pick people up from, and I can't see like people having their heart and soul in the shacks that I've seen around. I just can't. I don't think they do.
Which model is suitable for slum redevelopment?
So that is visited places.
Say that again?
Yeah. Slum redevelopment. For slum area.
Okay. Slum redevelopment.
Yeah.
This would be that. Yeah. So here we are. The same components that built the elliptical design and the oasis. Here they are. You can see them right here.
It looks like temple.
Exactly. That's why I did it in a way.
Praying place.
Heijung was. I have this in my yard. I have these armatures I have a building yard. I have these armatures, full scale, in my yard. You can walk around them.
Yeah.
You know. And Heijung was looking at it, and she said, the illustrator, she said, this should be a temple. Actually, you don't see there's a lot of beautiful things. There's a horn that comes out, because Thailand influenced me. The ways, and we didn't put it in this illustration. She changed it slightly, but the armature has a large horn coming up. And it's air and light. It creates the beam that lets the air and light in. That's what it does. Let's see. Maybe I can conclude with something very civil engineering orientated. I actually built this. Unfortunately, I have other USBs that I thought maybe I'd have the time, but I didn't. So here we are with this, and someday you'll see them all. In Staten Island, New York, I was asked, there was this hill overlooking the beautiful bay of New York City. It was, people were losing their yard. The house foundation was there, but next to it was going away because it's extremely steep. And they didn't want to do railroad ties because they had, and they were rotted out by then. So they said, oh, and do you think, and nobody could put footings in. It was illegal to dig into the hill. And also, the footings would have been amazing for any kind of wall. So I said, I hung out in my head, and I said, I think I'll cantilever this thing. So we call this block a dead man. Something doesn't move. So I made dead men, and I had concrete beams, or I'll call them ferrocement concrete beams, and a substrate. See this right here? This is the original grade, that line right there, say. So it's eroding away, and it's making a floodplain below. I'm talking about now, here, not now. This picture. And so my idea was, because I had seen step farming, they could either farm here, or it could continually go on a mountain road and save a road. In Mexico, there was perfect places for that. They would close the road. You almost have to dig your way to go where I built this house. So I thought of this, and I have pictures of the construction of it. They're not in this presentation. But anyway, I thought, you have a road, and remember, this wall doesn't have to be dime straight because it's ferrocement. Ferrocement does what I had said. It follows any form you want. So this would be like a ribbon following a road. And the water would go down, hit the slab, and the geotextile, which would capillary the water back. I'm sure everyone knows what a geotextile is. I learned about it in Angeles University, had a presentation, and I was at it. So I learned about that while I was designing this. Anyhow, the water would go down, capillary back to a perforated pipe system that would store the water in a water tank under the dead man, which also would add weight for the cantilever. So if you're thinking, the mountain's coming down, it's going to knock this thing off. Somebody told me that. That's not going to work. I said, I don't think so. You know why? Because now, you know how plants colonize? So now you'll let this eroded hill, it'll become vegetated. You probably have to machete your way through it because it's not getting washed away. So now you have new land when the mud plain dries, a place to put, same building that was built in Mexico, but it elongates. Same components. Very important. It's all the same construction. I personally think it's very important because I've run crews of 10 men. They don't know what they're doing all the time. It's like they're your hands. They're good men, but they better know what they're doing or nothing's going to happen. So we designed a few of these, which you see in the previous. These are like garden apartments. Now you have an option. You have a tank full of water, which will gravity feed to feed these factories or houses, pressure water. Or if you have too much water, which you would if it was long, you could send it far away where people need water because it's elevated. And if this is in an area where it's wet, you could send the water to where it's not wet. So there's a lot of options cooking here. I think I'm finished.
You spoke about forms being used for getting structures.
Forms for?
Like using form-finding methods to build structures for ferrocement.
I don't mean forms like you pour cement in the form. No, templates.
No, the way of finding forms, like using catenaries or different types of getting curves where the force follows the form.
I have templates for these components.
And the question is, what techniques did you use to get the templates across? Like, what were the forms
I use radial line development. And, to make the form, fabricate the form?
Yes.
Conventional rebar technology, two benders.
No, for example, to get the curves across.
Yeah, I use radial line development, which is where you have if you draw a silhouette, you project it over. You project over to the silhouette and you graph it, and you flip it around, and now you have more or less a three-dimensional view of the shape you want. But these designs were based on an ellipse. So it wasn't very difficult. I actually didn't use the radial line development for that. I used it for the curve coming around, and I made that turkey tail. You know, there's a lot of things that aren't here that you can't. This is the Ferrocement wall being built on Staten Island. Excuse me. See what I'm talking about? I don't know. I went in order and it stopped or something. Oh, good. That's what that armature is. They must. I bet you there's more. Now that I've found these, I don't know where they came from. They pop. Okay, that's in my yard. You see the snow covering a cage? It's up there.
Yes, yes.
Okay, that's what I built in my yard. The armature for this particular design. And originally, I thought it to be a medical center.
Okay.
So we made it look a little more sophisticated than. It doesn't have a fish farm around it.
Okay.
Well, it probably should. But there's the armature. And you see right here, right there, that is actually 5 18-degree angles, which gives you 360 degrees, or 90 degrees on each side, 180. And that's how all of these buildings get built point-to-point construction. It's built in the components. You don't have to lay anything out. You put up one component and it happens.
It is very difficult to fabricate.
It's genomic. I think it's called gnomonic.
Sorry?
G-N-O-M-A-N. I think.
Yes, gnomonic. Yes.
Okay, that's what it's like. It's like a flower. It keeps going. And I'm trying to show it. You see that? I don't know if you see a yellow up there, a little bit. Like yellow paint?
Yes.
Okay, that's what I call the turkey tail. It's like this. And they're 5 18-degree angles. This is from the radial line development. And they create 90 degrees. So you get 180 degrees happening. Okay. And from there, when you build this building, say, here's a better one, that you can see it better. The snow's covered in. If it was hot out, the snow was. You see
Thank you,
right
sir.
here? This is good. You see right here? Here's how I lay things out. You see the. I'm glad this stuff's here. I didn't know it was here. When I move this. Okay, right here.
One more question.
Yeah, one more question. We'll finish.
Thank you, sir, for sharing us so beautiful projects out of India. First of all, there are some queries. What software was used for analysis of such critical designs? The next question is regarding in your backyard, the structure you have prepared, then snow load was there. And what about seismic and wind loads? There are some queries regarding those type of loading.
In other words, I built it first. I just went down to Mexico with some templates I made that I imagined. Like this. Looks like this inside. He said, come down. That's why I went there. I happen to know a lot of the hombres up in the mountains from New York. That's the beam that makes that air and light down the center of the building.
You use the shadows.
And the way I laid it out was from the sun's shadows.
Wonderful.
Because I was looking at I think it was like a cathedral in Oaxaca, and the stairs matched the shadow perfect down the wall. I'm like, man, these guys were like, nobody was over there measuring anything. They were drawing that shadow. So that's where that came from. No, and the beam worked. You see it probably in, it's called the Portland cement. It's got its own, what do you call that earth? Is it pozzolan? What do you call volcanic earth? Okay, it has its own, I'm telling you, it's like, man, this is great cement. Here you go. Okay, there's the beam. And by the way, those columns, the seniors put them in when I wasn't there. I would come down for 10 days, and we built a cistern, and we started the house, and they said, Senor, and we no entiende this casa. And they put the columns up as if we were doing a building that, like a slab roof or something. I said, we don't need them, but here they are. In fact, Naveed said, they're making it weaker. They're point load the earthquake. They'll break where the columns are, that's all. So anyway, that beam up there, which lets air and light in, was laid out by the shadows.
I'm just curious, on your first slide, you had like some kind of heat map going on over your render, right?
On my what? First slide?
On the first slide, your introduction slide. Yeah. So what is it trying to say? What is that supposed to convey?
That's the way that Naveed Anwar, Dr. of AIT, that's the way he calculated all his calculations. Okay. In other words, I have it with me actually. I'll show it to you. It's a report that Naveed did. That's when he started telling everyone, and they built one on top of the roof at AIT. They built one of these.
Stress.
Anyhow, I believe it's a computerization of.
How do you camouflage the rainwater harvesting system into it?
Camouflage.
So you said you were supposed to store the rainwater. Every square feet of your roof is supposed to store the rainwater and stuff.
Go to where the four of them are at the end. That's a very nice question. Because it goes with, the whole system brings it with it. This is a gutter. This round, that's collecting the water. You can walk around the house in it.
Right.
And then,
where does it store?
the cistern, you see there's a line right there?
Right.
Okay, that's the slab. Under there, before we put the house there, we formed using ferrocement as forms, not wood forms. We formed a foundation that's holding this house.
Right.
Remember, look where it is. It's in a hill.
Yeah.
It's a pretty rough place, actually. It dropped 40 inches in 40 feet, 45 feet, the elevation. And in that elevation, we put the cistern.
Okay.
So below the house is water.
Right.
And what's really nice is it cools the floor. And the house, because it has that tunnel, that beam on top of it, which by the way is a ferrocement beam, and the circles make it very light. So you don't have to support the beam. Naveed really liked that. I think they did it at AIT again. No, the water's in a cistern under the house. And because they're up high, could all happen anywhere. By the way, there's no special. You can see the slab in the top corner picture. That's the slab being built. That's the slab. Okay, and they had to make another cistern because they had too much water. Like it collected, because the gutters are so big, it collects a lot of water when the storms come. It seems to have a magic of its own. In other words, it does a lot of things. And that was just, I noticed they were cooking outside when I was there. And I had designed this little building. That's when I discovered there's a ratio that any of these buildings can go like this. They can expand or contract. Same building system, I have a ratio for all the calculations. Okay. So you could have a building.
Parametric design.
It's pretty, it's gnomonic, it's called, yeah. So anyway, it's a lot to kick around, but I think it could solve a lot of problems because it is self-sustaining and it's very easy to learn. It's not hard.
It seems there are many innovative ideas hidden now, camouflaged like you are explaining. So to understand those, I think we need more time to discuss. Of course, we can certainly discuss in break time. I have another question regarding retaining wall. We are having problems like landslides, having the steep slopes in hilly areas, particularly in our Konkan area. So I found this solution, can it be used for slope stabilization?
Slope stabilization, like terrace farming.
Pardon?
Like terrace farming.
Yeah.
Yeah.
Terrace farming, because here the purposes are combined, like collecting the water and utilizing, again saving the retaining wall from the water pressure. Collection is a very unique way done with the river slope and collecting in a tank. So all these ideas are combined together. But for slope stabilization, can we make just a chain of retaining walls around the hill slope?
You know, I thought of that. In fact, it's in one of the illustrations of the villages. There's up in the mountain valley, there's a whole group of them going up. But they may not like the fact that the water stops. But I have a feeling there's a lot of runoff on terrace farming. I have a feeling there's, even though they're ancient and they existed a long time. But I have not been to it anywhere where there's terrace farming, so I don't really know the problem. But it's hard to say. But I could certainly see it physically, like doing it. Yeah.
Thank you.
I like it for a road, actually. I like the idea because it goes like this. In fact, the lady that I built that wall for wanted me to keep going, but her neighbors said they don't have the money or something. So they were letting their hill run away.
Yes, thank you. Thank you very much, Owen, for your presentation. It's always nice to listen to you. And as you can see, this passion shows up. He's been coming for the past 10 years continuously. And he's visited all the slums around and seen what solutions can be done. He's told me, I shared a little bit with him about the highway system also. He's got a lot of ideas and a lot of things to learn from.